Hello friends, this is Shivakkumar again, and today we are going to see the hot topic in instrumentation, that is actually the computer control of process, right? Actually PLC, DCS, SCADA, all these things. So this is this is main about the plant automation, right? Actually, the field instrumentation devices which is sending the signals to the central control DCS, from where the commands are given and inputs are received. So the instrumentation engineer actually should know about the computer control of process basics, need for a computer in a control system. So how the closed loop functionality will work, how the open loop will work, and functional block diagrams of a computer control systems, data logger, multi data logger in the sense actually it's a kind of information systems where data current status of the equipments can be sent to the engineers in the control room, and multi-channel data acquisition systems DAS, supervisory control data acquisition SCADA, direct digital controls DDC, and microcomputer interface types, common microcomputer input output methods, programming parallel interface adapters, and microcontrollers and applications. And then mathematical representation of sampling process, Z transforms, properties of inverse Z transforms, pulse transfer functions, data holders, transfer function of zero order hold, sampling frequency consideration, selection of optimum sampling periods, open loop and closed loop response of sample data control systems, and then control algorithms, PID algorithm, position and velocity forms, deadbeat algorithms, digital equivalent to conventional controllers, and stability of sample data control systems, Square-Cohen stabilization criterion, modified Z transforms to the system with the dead time, right? Smith predictor algorithms. These are the very important things. Z transforms in case of process controls, and then system modeling and I can say identification, mathematical model of for process, first order, second order, and the process, and second order process without and with pure delay, high order systems process modeling from step to test data, pulse testing for the process identification, time domain process identification, linear least square algorithms, and then finally we have distribution control system DCS, significance of DCS, configuration, then communication facilities, types of display, programmer logic control PLC, configurations, ladder diagrams, relay-based PLCs, computer-based PLCs, and interlocks. So interlocks is very important. Actually, say in PLCs and DCS, we have interlocks. Lot of interlocks are there. Under node logic-based gates, which satisfies a condition, which pressurizes to complete a particular logic. So if you want to open the particular mainstream wall, so you need to have some conditions prerequisite to open a wall, right? So those are called interlocks. So if that is fails, the mainstream wall will not open. If that is success, then mainstream wall will open. So 2 out of 3 guns should be operated, should be stabilized, frame should be stabilized, temperature. Like that, we have some temperature conditions, because why we are doing this conditions in a real time, because actually say once a boiler should be prepared for the I can say the firing as well as flame stabilization to be done, then only you are able to open the mainstream wall and send the steam pressure to rotate the turbine, right? Otherwise, without boiler preparation, how you can open the mainstream valve? It is not possible. So you cannot run the turbine. So that will again cause a trip to the unit, right? So all these conditions will be given as a logic, and so actually the DCS will be connected to the say data client server data system setup will monitor all this logic. So it will check all the feedback from the field controller and say if these conditions are satisfied from the field, then only it will allow the control room operator to or either open the wall or close the wall or control the throttle the midship walls and everything actually. So all these things actually depends on the DCS logics actually we have implemented in the central control systems. And for knowing this computer control of process, we have two textbooks, P.P. Deshpande and R.H. Ash, Elements of Computer Process Control System, Instrument Society of America, published in 1981, and C.L. Smith, Digital Computer Process Control, um, in Text Educational, publishes 1972. And for references, we have a lot of books. C.D. Johnson, Process Control Instrumentation Technology, Prentice Hall Incorporation, third edition, 1988. And then SI Hassan, Microprocessor with Application in Process Control, Tata McGraw-Hill in 1989. And MP Lucas, Distributor Control Systems, Van Nostrand, Reinhold Company, 1986. So, you people may think actually how you know these kind of authors and books means actually when I'm working in my domain power plant and all other companies actually they have libraries and have gone through these books. So otherwise actually even I cannot know the foreign authors and everything. So I just make a note on that. So I was in an assumption that actually so it might be very useful in the future, but I really don't know. I was engaged in sorry, I'm engaged in doing YouTube's. So those data can be shared now. And thanks for my actually the previous companies and everything. Each company, previous company is my stepping stone to reach this stage, right? So it is my recommendation actually. Whatever you learn with you share with your friends and other peoples. So that will motivate someone to begin to reach a big one. And finally, our India will get good, huge benefit on that, right? We will get a lot of scientists and engineers on each other topic. So that is why I'm sharing the book details. So I hope actually this will be more useful for you guys. Thanks, friends.